The topic of our flash talk is green building. Next. So first we're talking about how is green building different from the others. So the green building, it focus on the they focus more on the planning, design, constructing, and operation building with several consideration, which includes energy use, water use, indoor environmental quality, and material section, and the building effect on site. So they don't just build the building for their needs. They care about the impact on the society and the area. So we're talking about three cases. The first one would be Billet Center in Seattle, USA. The second would be Harvard House Zero, and the third one would be the Crystal. So for the Billet Center, Seattle, USA cases, it is built in 2013, and type of the building is office, and the size is 50,000 square feet, and the rating system is by Living Building Certification. Next. Next. Okay. So there are six features that I would like to introduce. The first one would be net zero energy use. The second would be solar panels, and the third would be heat pumps, and the fourth would be heat recovery ventilation. Fifth would be regenerative elevator, and the sixth would be rainwater harvesting. So for the first one feature, the net zero energy use, all the building energy use would be supplied on the renewable energy on site. And so if you look at the chart on the right, you'll see that in summer, there are energy surplus, while in winter, there are energy deficits. And so in the summer, they produce more energy, and they transfer the energy to the power grid. And when the winter, they don't produce so much energy, they get energy from the power grid. However, uh, in the total year, when we sum up the energy, there is net zero energy use. Next. So the next feature is the solar panel. This building has 575 solar panels, which generate more energy than the building use a year. So 1 meter features energy sold on the electric utility is purchased, and there are 230,000 kilowatt per hour hours per year is expected to be generated by the photovoltaic array. Next. So when the heat pump is a very big feature of the buildings, because the weather could be cold in the winter, and the heat pump help keep the warm in the building, and which reduces the consumption of surplus energy. Next. The heat recovery ventilation, which provide fresh air, and we use tempered exhaust air from the building to heat the incoming air. And it has a special special honeycomb heat transfer will return slowly to maximize the heat transfer and prevent the cross contamination. So the fresh air doesn't get contaminated by the exhaust air, but it gets warmed by the exhaust air. And it is approximated to transfer 65% of the heat. Next. So the next feature is regenerative elevators, which is developed by engineers at Cone, which is a company. And the elevator works in a way like a Toyota car named Prius, which generate energy when the elevator just slow down. So it make use this energy into electricity. Next. The last feature I would like to talk about is rainwater harvesting. So the 100% of the water used in Bullet Center come from rainwater. So they don't have to rely on other facility. You don't have to get water from outsource, and it is more environmental friendly. And the great water is treated and reused in vacuum flush toilet system, which make the most use of great water, which save waters and make the environment more clean. The next would be my partner's part.
Okay, so I'll be talking about the Harvard House Zero project. It is a project that a group of students revamps a house and turn it into a energy saving house with intelligent methods. So it has four main targets. The first one is zero energy required for heating and cooling. The second one is the 100% natural ventilation, and the third one is the 100% daylight autonomy or no daytime electric light, and the fourth one is the zero carbon emission. So to achieve zero energy for heating and cooling, they implemented a method called data-informed building energy management, which we'll be talking about at the next slide. And for the extreme conditions, they implement the geothermal heat pump for extreme hot or cold conditions. And the solar strategy is also implemented, like the specially shaped window shells to for example block the sunlight at the summertime to reduce heat in the house. And the data informed method is like you have the environmental data, like the temperature of the outer environment, the electric usage of the house or the hot water in the house, and the house will collect the data and try to predict the how will the things go, and to at first they can operate the systems like the windows or the heatings or the geothermal pump heating systems. So they can reduce the waste of like like reduce the possibility of overcooling or overheating in during day or night and nights. And the natural ventilation is achieved by controlling the windows. Controlling is they have automatically control windows to make use of the natural flow to help ventilation. And for the underground levels, they use solar vents. So solar vent is the sunlight will heat up the upper part of the solar vents, and the air will air at the upper part will go up and bring up the air in the underground levels to achieve ventilation. And for daylight autonomy, so yeah, so they make sure that the sunlight is they make every inch of the sunlight during day. So they implement the windows, large windows and skylights, but with high insulation to make sure that the environment, the temperature in the house is stable. Okay.
Next, I'm going to talk about the Crystal. This is a building in London. This is previously an exhibition center and is now the City Hall of London. Next. So the Crystal is a quite green building. It compared to standard building that it reduced 42.6% energy consumption and reduced 7.1% greenhouse gas emission. And it used some techniques like triple glassing and natural ventilation, chill beams, heat pump, and solar panels. This technology helped to make the building green. Next. So this is an overall system of the building. It's a 100% electric building. 20% of the energy comes from the solar panel on site, and the other comes from the power grid that comes from green energy. And it uses ground source heat pump to provide 100% building heat and cooling. And for reducing energy use, it uses systems like chill beams and natural ventilation to reduce the energy. And it also has rainwater systems to recycle the rainwater and make use of them. Next. So this is a figure of the energy income and energy usage. It has been divided to two parts, electricity and thermal. So as you can see the figure, the power, the PV panels and the electric grid provide the electric energy, and most of the electricity is used in applications for exhibition. And for thermal energy, the most source of energy comes from the ground source, and the most usage of them is used in the cooling. Next. So for light, they have developed some special technique for them. It uses triple glass windows. It is the 3-layer glass with argon cavities, and with those windows, the the window can allow in 70% of natural light, but only 30% of the thermal energy is coming in. And it has special design for daily light harness. Almost every place in the building have access to natural light. Next. So I think something is interesting is that it also has design about the building orientation. It investigated on the different seasons sun orientation throughout the day. And so from the investigation is they come up the result that higher proportion of glass in the east side is used, and this can make use of the sun heating in the winter. Next. And it has design about natural ventilation. At moderate temperature, the window will automatically open and the natural ventilation will be used. And for other temperature like the high temperature, the mechanical during the day, the mechanical ventilation will be used, and natural ventilation can be used in nighttime when the temperature is cooler. Next. So it also have features like ground heating. It uses 100% of natural heat source. No fossil fuels are used. And it uses 2 ground heat source pump to create hot and cold water respectively. And the water are provided for the building's cooling and heating. Next. So it also make use of rainwater. It collects water from a 30 meters squares tank, and 100% of fresh water is taken, and it recycles gray. It has systems that recycle gray water. Okay, this is the end of our presentation. Thank you for your time.